talk about quadrilaterals. A quadrilateral is a shape with 4 sides. So what are quadruplets? Anyone know? If somebody has quadruplets, what are quadruplets? Right. Quadruplets are having 4 children at the same time, right? And 4 babies is quadruplets. And if you've ever seen quad rule paper, it makes little squares, right? Graph paper is covered with little squares. Yeah. So a quadrilateral is a 4-sided shape like a square or a rectangle, right? Um, so um, if you've ever heard of a quadratic equation has a squared term in it. That's why it's called a quadratic, because it has something that is squared in it. Aha, square, quad. Okay. Now, quadrilaterals are 2-dimensional figures with 4 straight sides, 4 angles, and 4 vertices. What are vertices again? Anyone remember? Corners, points. Good. Yes. Whichever you want to call them, corners, points, I'm happy with either. Corners or points. Does anyone remember what's the singular of vertices? Vertices is plural. Does anyone remember the singular? Good memory. Vertex. Vertex. Good. Really good. Um, so this is a rectangle. It has 4 sides, 4 angles, and 4 vertices. A square does as well. The key difference between a square and a rectangle is that in a square, it has 2 pairs of equal sides, whereas a square has 4 sides that are all equal to each other. Now, this third one here is called a parallelogram. A parallelogram is a bit like the rectangle. Moses, I'm sure that Sasha has that PDF for you. So a parallelogram is kind of like a rectangle in that it has 2 pairs of equal sides, but the angles are not 90 degrees in a parallelogram. And then there's also something called a trapezoid. What makes something a trapezoid is that it has 1 pair of parallel line sides. 2 sides are parallel to each other. Now, we haven't talked about parallel, but parallel means they're like train tracks. They go next to each other forever. They never get further away. They never get closer. They just stay exactly the same distance apart the whole time. So if you look at a trapezoid, in this trapezoid, the top and the bottom are parallel to each other, but the left and right sides are not parallel to each other, and that's what makes it a trapezoid. You guys are ready to try something a little bit trickier, okay? Now, I know this is a little tricky, but I think you can do this, all right? I'm going to be quiet and let you guys try it for a little bit. And after like maybe 45 seconds, I'm going to pop back in and give you a hint on how to keep going, okay? So I do have some ideas, all right? But I'm going to let you guys start it on your own, and then I'm going to give you a big hint, and then we'll review the whole thing together. Got it? All right, I'll see you in a moment. Okay, this is my hint for you. Anytime they ask you for the area of a shaded region, like when they color in part of it and not the rest of it, you find the answer by finding the area of one shape and subtracting the area of another shape. So you'll have to do a few distinct steps here. See if that helps you a bit. We'll check back in about another 45 seconds. Keep trying your best. All right, so remember, shaded region, subtract. Shaded region, subtract. Let's talk about it. All right, so, oh, I'm glad that was helpful. Thank you. All right, let's see. Now, the grass portion is everything in the yard except for the patio. So our big plan is going to be to find the area of that whole rectangle, then we'll subtract away the patio. right? And that will give us the grass, right? So the big rectangle, and we'll subtract away that small white rectangle, and that will give us the gray rectangle. So let's find the area of the big gray rectangle. That would be 18 times 24, right? Length times width. So the area of the big rectangle is 432. Again, you can ask your calculator for some help on that. You're like, hey, calculator, what's 18 times 24? Calculator's like, I got you, bro. It's 432. Okay. Then we find the area of our little patio. The patio is 9 by 12. Again, we ask our calculator, hey, calculator, what's 9 times 12? It says it's 108. So for our final step, we're going to take the 432 and subtract away the 108, and that gives us 324. Yeah, which is a match for choice C. So if you either got it right or feel like you learned something from the process, which is just as important, give me a smiley or thumbs up. If you feel still very confused, go ahead and ask. So private chatter, this is my first time joining live classes. This is a way to view previous lives. Aaron, reach out in Q&A. You can access it through the More. And we started at 8 o'clock Eastern, so you might be joining a little late, but reach out in Q&A and Sasha can help get you up to speed, okay? Because we want to make you feel like you're up to speed, all right? We're here to help. We're glad that you could make it. Let's talk about perimeter and area. Perimeter is the distance around a figure. If you ever watch like, I don't know, like an action movie, like a Marvel movie or a cop movie or, a heist movie or something, you may hear like a police officer saying like, let's establish a perimeter or something like that. That means we're going to put people all around the outside of this building or whatever it is that we're doing, right? So if you ever hear them say, we have to establish a perimeter, that's what they mean. They're going to put people around the outside of something. So perimeter is the distance around a figure. Perimeter is measured in regular units. So if you're sitting there going regular units, as opposed to what? As opposed to square units. We will get to that shortly. But it would be inches, regular inches, not inches squared, but inches, centimeters, meters, miles, kilometers, anything that can measure distance. Now, to find the perimeter, all you got to do is add up the lengths of a side. So if we look at this shape here, we can see that along the top, it's 5 along the top, and it's 3 along the side, right? So along the top is 5, right? And along the side is 3. This side is also 3, and this side is also 5. What would the perimeter of this rectangle be, my friends? You got it. A lot of you are like, it's 16. It is. Yep. You're really close, Olivine. Just check arithmetic one more time and you'll get it, right? So yeah, we got 5 on the top, 5 on the bottom. That adds up to 10. And then the 3 on one side and the 3 on the other side is 6. So 3 plus 3 is 6, 5 plus 5 is 10, and then 6 plus 10 is 15. So, or sorry, is 16. Sorry, 16. The perimeter is 16. The perimeter is 5 plus 3 plus 5 plus 3. Those of you saying 15, I think you're finding the area. We will get to that. So our perimeter is 15. It's 16. It's 16. It's 16. Sorry. It's 16. It's annoying that they're so close, but the perimeter is 16. Now let's talk about the area. If we want the area is measured in square units. So square centimeters, square inches, square miles. So to find the area, you have to multiply the length times the width. And as some of you are saying, it would be 5 times 3. So in this case, the area would be 15. So the perimeter is 16 and the area is 15. So if any of you said 15 before, you had the right answer to the wrong question, right? So I was like, why are people saying 15? And now I understand. So you didn't make an arithmetic mistake. You were just a step ahead of me, and that's cool too. So you knew that the area is going to be 15, and that would be square units, and then the perimeter is 16 regular units. All right? Okay. Don't worry, we're going to practice. We are going to practice. No, I keep doing that. Okay. Clear. There we go. All right. So for certain two-dimensional figures, you can apply a formula to find the perimeter. Um, they give you the formulas, but it can still be helpful to memorize them to save you some time. To find the perimeter of a square, it's one side times 4 because all 4 sides are the same. So adding up 4 of them is 4 times one of them. A rectangle is 2 times one of them plus 2 times the other of them. And to find the perimeter of a triangle, you add up the 3 sides. So for example, in a square, the perimeter is 4 times the side. In a rectangle, the perimeter is 2 times the length plus 2 times the width. And in a triangle, it's the 3 sides added up. Now for area, um, you need to multiply. So for a square, it's side times side, also known as side squared. For a rectangle, it's length times width. And for parallelogram, it's base times height. Notice that in a parallelogram, one of the dimensions that you're going to use that you multiply to find the area is not actually going to be one of the sides of the shape. It's going to be a line that you find. There has to be some way for you to find it. Maybe they'll give it to you. Maybe you have to do something with triangles to find it. I told you, whenever you don't know what to do, it's probably something to do with a triangle. But somehow or another, you would have to find that line. The base and the height must meet at a 90-degree angle, and the height in a parallelogram will generally not be one of the sides. It will be a line that you like sort of draw in yourself. Now, for some two-dimensional figures, you need to use a formula, like you really need to. You may not be able to like magically understand. So for triangle, it's 1/2 base times height. Notice that with triangles, like the height sometimes is a line that you draw yourself. And same thing with trapezoid. Again, a height is in the trapezoid a line that you draw yourself. The base and height of any two-dimensional shape that you're going, or yeah, any two-dimensional shape, if you're going to do it like base times height, you have to multiply, you have to draw in the height yourself, and they have to meet at a 90. We will, Alexandros, we will. Don't worry. So, um, so we're going to do a mini practice now. So, um, first we're going to practice deciding if you need area or perimeter. So, if you're putting up wallpaper, what do you think you need, area or perimeter? You're going to buy some wallpaper, you're going to put wallpaper up on your walls. Yeah, it's going to be, you need to think about how much space it's covering, right? Not just the edges, but the space. That's area. This would be area. Cool. Now, what if you're putting ribbon around the edge of a picture frame? Is that area or perimeter? Yeah, that's perimeter, right? That's perimeter. When I was little, I had like a border around the top of my room, like a flowered border. So that would be like perimeter, right? Yeah, like wall trims. That could be perimeter, right? What if you're putting a fence around your garden? Is that area or perimeter? Yes. Putting a fence is perimeter, right? That's the outside. That's the outside. Really, it's just perimeter. You just need to know perimeter. It's just around the edge, right? So you need to know how much space, like to line around the outside. That's perimeter. What if you're putting carpet? Well, height is something different, right? You just sort of decide how tall you want the fence to be. Now, for carpet, you probably want to know that's more area, right? Not the kind of carpet where you buy a rug, but like you're putting down wall-to-wall carpet, right? And you're buying it by the square foot. That's area. Yeah, that's more area, right? So we're just trying to like get used to area and perimeter. There can be exceptions to all this stuff, but we're going big picture here because what if you get a word problem, right? I want you to start in the right place, finding the right thing, right? What if you do a really good job finding the area, but what you needed was the perimeter? That would be frustrating, right? So um, take that moment to be like, wait, is it the inside or around the edge, right? Yeah. Um, so if you're looking for a new home or a new apartment, you'll often see the space inside measured in square footage. They'll often put that with a little FT and then a little square. That means square footage. They're measuring the area inside, right? Um, okay, so here's our little mini practice. So we're going to say that all of these are shown in centimeters. So for number one, what would the area of that first one be? Here, we're practicing triangles with a little drill that's not in your PDF. We're just practicing finding the area of a triangle using formula. Remember, D, one thing, check the formula again. What's missing? Nice, good catch, LT. Good. Remember, area is 1/2 base times height. We have to remember that for triangles, right? Because you know that the test maker is going to put 48 there as an answer, right? For somebody who forgets to cut it in half, they're always going to do that, right? Don't like it, but they're going to do it, so we got to be prepared. Yeah, no, 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 no. Yes, I didn't say it yet. That's true, D. I knew you knew. I just thought maybe you'd forgotten. But yes, you got it. You got it. Good, good. All right, good work, everybody. Let's do one more. For the letter B, what are the base and height? What are the base and height? Good. Our base and height are 8 and 11. Nice. And so we'll use our area formula, 1/2 base times height. And good. I'm seeing it. Nice. Good, really good, you guys. It is. It's 11 times 8 divided by 2, which, as a lot of you are saying, is 44. Really, really good. Now, this last one's a little bit of a trick. I'm just going to turn off chat for just a second, let you guys try to figure out what do you think the base and the height are, and what would the area be. I'm just going to be quiet for just a moment and let you guys decide. What do you think? We'll check in with each other in like 20 seconds. Okay, friends. Yeah, the base is the bottom. Exactly, Matthew. Yes. So the base and the height, as you are saying, are 10 and 17. Really good. Really good. Notice that they're not touching each other, but if we extended the lines, they would meet at a 90, right? So we do 10 times 17, but divide it by 2. And we do, in fact, as some of you are saying, we get 85. So now we have practiced. You guys killed it. Yeah.